Hello guys and welcome to this new video. I'm very excited to have you in this lecture where we have been building up the concept of .NET Core, some things that we need to have in mind before really understanding the framework, like we saw in the previous lecture about a static versus dynamic websites. Also, we dive into a little bit of what is server-side rendering, which is pretty important to understand, and differences between this approach and the API empowered website, which basically .NET Core can be used to build both of them, right? And now we're going to be studying a little bit how this framework processes an HTTP request. This request enters into our application. There's so many things that happen in between, and then our application basically responds with a so-called HTTP response, right? So we're going to be studying a little bit how this works behind the scenes, and with no further ado, let's begin. So as I told you in the past lecture, we're going to be having this kind of slide every now and then with basically the topics that we're going to be studying in the video, which in this case we're going to be studying about the Kestrel development, which I mentioned before that one of the main goals of .NET Core was to be able to be developed and deployed into different platforms, right? Or in other words, to be cross-platform, which before was a limitation. So we're going to be studying how that was possible, and it's because of the Kestrel. So we're going to be studying into that. And as I explained before, we're going to also be studying how basically .NET Core process an HTTP request, all right? So we're going to be building up this definition throughout this lecture and in the upcoming ones, all right? So now we're going to be studying some interesting diagrams that are going to be explaining basically the architecture before and after the development of the Kestrel, which basically the Kestrel is the one that enables cross-platform for this new .NET Core framework, all right? So basically in the previous ASP.NET framework, the hosting model relied completely on Windows IIS to provide the web server hosting, all right? So there was basically a tight coupling between the web application and the underlying host. This was a limitation because this only enabled the applications to be developed into Windows architecture, all right? So to make possible a cross-platform approach, an alternative hosting model needed to be adopted. Basically one that separates the web application from the underlying host, right? So basically the solution to this was the development of the so-called Kestrel, which in simple words is a fast cross-platform HTTP server on which ASP.NET Core applications can run. Okay, so in the previous design, Windows IIS was the responsible of calling into specific points of the application. As we can see in the first diagram, this is the architecture before. So we have this agent or this hosting model called IIS, which was sitting between the internet and our application. So basically the request from the internet or the client was received by IIS, then it invoked methods directly into our application. Our application processes the corresponding business logic and sends back a response but to the IIS server, and then the server sends back the response. So basically there's a back and forth messaging between IIS and our ASP.NET application, right? So as you can see, there was this tightly coupling between both of them, so this limited a cross-platform approach. But now with the development of the Kestrel, ASP.NET Core applications basically are console applications that they self-host a web server and handle the requests directly. Alright, so now with the Kestrel development, we can switch the approach, right? And we can analyze this second diagram, which is sitting below, which is basically that, as you can see, the ASP.NET Core application has a self-hosted web server that is in charge basically of processing the requests and passes it to the rest of the application. There's so much more going into this in understanding how this Kestrel processes the request and how it sends it to the rest of the application, so the application can basically understand the request. But we're going to go into that later. But for now, what I want you to understand, or the main difference, is that the web server is self-hosted into our application, right? So basically, we have a request. Also, we have a new entity in here, which is called a reverse proxy, which basically a reverse proxy sits in front of our application, as you can see in this example. But we could also expose directly our ASP.NET Core onto the internet, right? Because the Kestrel will be able to receive the request directly. But the most common scenario is to use a reverse proxy, which is going to be sitting between the network and our application. Also, the reverse proxy responsibility is to basically receive the request and forward them to the corresponding web server, right? So the reverse proxy is going to be exposed onto the internet. Meanwhile, the underlying web server is exposed only to this proxy. So basically this ensures security and performance for the web servers, right? It also enables the separation of concerns, right? So it's a good practice that you're going to be seeing very commonly. But what I want you to understand is that before IIS has a tightly coupled relationship with our application, as you can see in this first approach. But now the reverse proxy simply handles the raw requests that comes from the network or the client and handles it to our self-hosted web server or the Kestrel, but simply has no deeper understanding or knowledge of our application. As you can see in the first approach, IIS was in charge of invoking methods directly in our application. But with this new approach, the reverse proxy is only focused on proxying the request to the corresponding web server, but has no deeper understanding on how the application works, okay? That's one of the main differences that we can see. And basically, the responsibility of the Kestrel is to receive the HTTP requests and generate HTTP responses. So before, IIS was the responsible for this, but with this new approach, the Kestrel is the one in charge of it, okay? So those are the main differences between them, and this is how basically cross-platform was enabled by the build of the so-called Kestrel, which is in simple terms a self-hosted web server into our application. So as we can see, we could expose this directly onto the internet, but for security, performance, and separation of concerns reasons, it is most common to use a reverse proxy that is sitting between our application and the network. It receives all the requests, makes some validations, and in case they are correct, are secure and stuff, then it forwards them to the corresponding web server, and that's it. It doesn't know more about our application, and basically the Kestrel is in charge of processing the request, passes it to the application, the application generates the corresponding response, sends it back to the Kestrel, and the Kestrel then sends it back to the proxy, which is going to respond to the client which made the request. Okay, so that's basically the flow and the difference between the two main approaches before and after the Kestrel development. All right, so we have been talking a lot about HTTP web requests and responses, and as basically .NET Core is a framework used for building web applications that serve data from a server. It is going to be a lot of requests and responses going on, so we're going to understand what is the flow when a request comes into the application and how the response is generated. All right, so basically the first step is that the user requests a web page entering a URL. For example, what I explained you before using Amazon. When we type amazon.com, that specific part of the URL is called a host name, which basically uniquely identifies the website by mapping the DNS, the domain name service, which is amazon.com, and that is mapped to an IP address internally, right? So by using domain name services, it is like easier for us, so we don't have to type, for example, 192.50. etc. We just use the so popular domain name Amazon, and that's it. And also, for example, if you type / shopping cart or something like that, that is called a resource. So a URL is composed by the host name amazon.com and by a optional resource or resources, in this case / shopping cart, and that is going to be used by the server to know what does it have to serve corresponding to the URL that the client entered. All right, so once the user requests a web page entering a URL, then the browser sends the HTTP request to the server. All right, so it is going to look to the URL, so it is going to know that the request is going to be specifically for a shopping cart inside of the Amazon server, and then the server interprets the request and generates the HTML and send it back as an HTTP response. So basically, as the server knows what exactly does it need to create based on the URL that was entered, then it is going to internally create the template or the HTML corresponding of other information like the user information, the items that the user belongs, the price, and so on and so forth. It creates the HTML that the user is going to see, and then it basically sends it back to the client, and the client can render the HTML. So that's basically the flow that happens every time that we request a web page. So it needs to go and look into the server for that specific URL. It generates the HTML, and then the HTML is sent back as a HTTP response, and then the client is able to render the HTML in our view. Okay, so basically this all happens using the HTTP protocol, which is the application level protocol that basically powers the web. For example, allowing this client-server communication so that both of them can speak the same language, so to say. It is also stateless because each request is executed independently, so without any knowledge of the requests that were executed before it, which means that once the transaction ends, the connection between the browser and the server is also lost, which is one of the main characteristics of the HTTP protocol. But what I want you to focus right now is basically this simple flow that is going to happen every time that we make a request to our server. All right, so I think that is the major highlight that I want you to focus. And now we're going to see basically how .NET processes an HTTP request. All right, so we're coming to the end of the lecture, where I want to finish with how .NET processes an HTTP request. We already went through the complex part, which is basically how this client-server communication happens using HTTP requests and responses through the HTTP protocol. So now basically we're going to see that is exactly the same flow. So the requests is received by the .NET Core web server, which is called the Kestrel, as we saw before. Then the Kestrel is going to send this request to our application, where we have the infrastructure and the application logic. Then it is going to generate the response. Then the response goes back to the web server, and then it is going to send it back to the browser, as we can see. So a pretty simple diagram and pretty simple flow, but we're going to be building more and more into this diagram to understand what really happens behind the scenes. And I think that it is going to be pretty exciting to really understand what is going on. And just one thing that I want you to understand, as we can see in the definition down below, the Kestrel is responsible for receiving the raw requests, as we saw before. For example, if we have a proxy, it is going to just send us back the raw requests. So the Kestrel is going to need to transform it into something that our .NET application can understand, right? So it is going to transform it into something which is called the HTTP context object. And now using this context object, we're going to receive information about the request. We're going to be able to write information about the response, as we're going to be seeing. But basically this object is going to be used for every request and response that comes and goes from our application. All right, it is a little bit abstract right now if you haven't seen it in action, but we're going to be understanding it more and more with the following videos. All right, but I think that it is important for you to have the whole view of how things work, maybe in a general aspect. All right, and now then, having all this knowledge and the ones from the previous videos, I think that we can now go into the fun part, which is the code. So I'm really excited to go into there. And then once more, I really thank you for watching this video. So if you have any doubt, any comment, please feel free to just leave it in the comments down below, and I will be responding as soon as possible. And I hope to see you in the next one. Thank you so much.